Alright, so today I'm going to be showing you all 14 algorithms of the LMCF beginner's method. And by that, I mean the beginner version of LMCF, not that many algorithms. There's only 14 if you don't count the corners. So yeah, let's get straight into this. So I was on a Discord server the other day, a couple days ago, and a guy named GodCubing said, "I'm confused. How do I learn LMCF? I watched a tutorial video, but I'm still confused on E2L. Montu said same, and I sent both of them to LMCF Google Drive PDF thing, and GodCubing said thanks, but where do I find these algs? And he sent me the table, and it's circled around all the LMCF beginners algs. And Chords came in and said for L6E there's a section for Waterman L5E. As you learn one set of the algs, it can set up to it every time. I said GodCubing page 31 will tell you. GodCubing said, okay, but how do I do E2L? I said, just like the other alg sets, recognize cases and do the algs. Cubing Forever said I do sets to comms, and he sent some commutators, and I'm not going to put them in this video, though. And I said, nice, I'm going to make an E2L or an L5E vid tomorrow. Little did I know I had no time tomorrow to make a video, so I just thought that was a ZBLS Shorts video. And GodCubing said that will gain you at least 1 subscriber. And I know it's a day late, but I had barely any time to do anything yesterday. So little time I had to do a YouTube Shorts video. So let's get straight into this. So the first, there's only 3 algs for E2L, and I'm going to set up. The first one is pretty short. Let me set up to it. And the first one is, if this here is an S move from being solved, and the current DB position is disoriented and should solve into UL. UL disoriented should be solved into UR. And in the algorithm for this, it's one of the easiest algs you're going to learn. It's U, M, U prime. And reflections exist, so you can probably do that to lower the move count, but that is the first alg. The second alg, I'm going to set up to it. Okay, so this here is solved and disoriented, and this here is disoriented and should be up in the UR. The alg for this, U prime M, U2, M2, U, or no, U prime, and that's how the algorithm goes. And the final alg, I'm going to set up to it again, is if UR should solve into UL and it's oriented, and DF is disoriented and should go into UR. The alg for this, M, U, M, U2, M prime, U. Those are very intuitive. I'm not going to break them down. I mean, I could probably break them down in a different video, but I'm not going to for this video, because, I mean, it's pretty self-explanatory. You just got to look for certain triggers for a UM algorithm. But that's basically all the E2L algs. Up next, we have 8 algorithms for last 5 edges. And how this works, after you do a total of 7 edges, you have 5 edges left. And there are 8 cases for the DFL set, which is the beginner set. If you learn one, you can set up to it every time with kind of an M, M prime, M2, D2, U2, rotations, blah, blah, blah. You could do that for a setup to the DFL set. So the first case here out of 8, how do you memorize this is, of course, DF currently is disoriented, so that's where the D goes, the top down. The white sticker here is in the D position in the DF edge, so it's the DF, and then L because this goes into UL, so it's the DFL set. So the first case here is if you see there are no disoriented edges, so you can just, by looking at these 3 edges, recognize the case if you see the DFL set case. And of course, all 3 of these are oriented. So how this alg goes, M prime, U, M prime, U prime, M, U prime, M prime, U. And that orients everything while solving this. So that is the first case. The second case here, again, we can cover up this entire R layer here. And what you see, you have one disoriented edge, and it's here in the back. And again, this is a DFL set case. So we have one disoriented edge in the back. The alg for this M prime, U prime, M, U prime, M prime, U prime, M, U prime. So it's basically M prime, U prime, M, U prime twice, and that is how the algorithm goes. Again, it orients everything while solving this. So that's kind of an easy algorithm to learn. The next case here, again, we cover up the entire R layer, and of course it's another DFL set case. What we see, we have two disoriented edges here in the back and the left positions. So the algorithm for this is U prime, M, U, M prime, U prime, M prime, U. And again, that orients everything, but if you want proof, there, now it orients everything. So, but yeah, it does orient everything while solving this, and that's the third case. Alright, so the next case we see here is, again, a DFL set case. We see here, next time, we have the front and the right edges disoriented. And, of course, this is another DFL set case. The alg for this, U prime, M, U prime, M prime, U, M prime, U. And that orients everything and solves the UL spot. So that's the fourth case. So the fifth case, DFL set case, obviously. And what we see here, we have the front and the back edges disoriented. So the algorithm for this is U prime, M prime, U prime, M, U prime, M, U, M prime, U, M, U. And that is the algorithm for this. It orients everything. In this case, I got an edge permutation skip, which is good, but it solves this while orienting everything else. So the next case here is if we see, again, cover up the R layer, and we see all three of these edges on the top here are disoriented. So the algorithm for this, U prime, M prime, U prime, M prime, U prime, M, U2, M, U. And that orients everything while solves this UL edge. So this next case right here is, we see only this front edge is disoriented. So the algorithm for this, U2, M prime, U, M, U, M prime, U, M, U prime. And that is, that case, it orients everything while solving UL. In this case, I got another edge permutation skip. I'm getting lucky. But yeah, that's that out. So the final case out of all 8 of these, the last case is if we only this edge, this left edge here is disoriented. In this case, the algorithm is M, U, M prime, U2, M prime, U. And that orients everything while solving this edge. So that is the last case. Now on to Midge permutation. So the last step is basically just Rule 4C step, which is just Midge permutation. So the first case out of 3 is called block. So we got a block here, another block here, another block here, and we got a lone edge. What we want to do for this case, we want to rotate the cube. Let's say you got it from this angle. What you want to do, you want to rotate, do a Y2 rotation. Make sure the block here, the big block, the biggest block is in the DF position, and this here is in the UF position, the lone edge. You want to do the algorithm U2 M U2, and well, that's pretty much it for that case. The second case is called bars and columns, and you can get this in a variety of different ways. So what it is basically a bar here, bar that goes straight through the cube, and a bottom bar here. So basically you just want to do U2, M2, U2, and that's the entire alg. And you can get it from this angle to where the top and bottom faces is solved. You can just do the alg again and it'll solve it. You can get them vertically, both of those cases vertically. Let's say the front and back is solved. You don't want to do M to bring it down, and then algorithm. And if you get it from this angle, you could just go do M and then algorithm. So that's basically the bar case. The final case is called flowers, to where we have the flowers right here. So it's just the centers. What we want to do, E2, M, E2. I don't care the angle you get to it, but that's what you want to do for the algorithm. So that's all of the algorithms for the LMCF beginner version, which is only 14 if you don't count the corners. So that's the end of this video, and see you guys in the next video. Goodbye.